Okay, solve for B. Well, we could write the equation. We want to write the equation. We don't want to just start doing things without writing out the equation, because we're going to do things to both sides of the equation. Okay, so what do we do here? Well, we divide both sides by AC. Well, you kind of know that that's going to get rid of B, but you haven't proven it. Okay, but you can rearrange this to AC over AC times B over 1 equals DE plus F over AC. Now we understand that's true because we know how to multiply fractions. If we multiply AC by B, we get AC times B, which is the same as A times B times C, right? Because it doesn't matter what order you multiply three quantities in, it's going to be the same. So this is just ABC, that matches what you have here, right? And the denominator is AC times 1, that's just AC. So that works. So we have 1 times B over 1 equals this. So B equals DE plus F over AC. Now, wrong solution. Try to subtract AC from both sides. Maybe put a line through A and C and put lines through A and C and it looks fine. But it isn't, because you can't do anything like this. Okay? ABC minus AC is AC times B minus 1. Okay. And at this point, I'm not going to go through entire analytical proof of the fact that this isn't right. But basically what you just did was, well, okay, this is still valid. This is still a valid equation because I haven't done anything that I didn't do to both sides. And obviously, if I multiply AC by B minus 1, I get AC times B, which is your ABC, minus AC times 1, which is minus AC. So there's nothing wrong with subtracting AC from both sides, except that it doesn't help. That's the only reason it's wrong. It's not what you want to do, but it's not an incorrect mathematical step. It's just a bad idea. Okay? There are lots of legal things you can do that are bad ideas. Okay? You know, it's legal to take your life savings and put it on a roulette wheel. It's not a good idea. Unless you're really desperate. The only way you're going to survive is to, you know, get 50 times your life savings. Maybe you take that chance. Okay? Hopefully you're not going to be in that situation. All right? Well, that's an example of a bad life choice in most cases. Okay? I mean, the only way you're going to survive is to have a medical treatment that's going to cost 50 times everything you know, and there's no other way to get it. Well, you at least got a chance of survival, not a good one. Probably going to die. Okay? But sometimes that might not be a bad choice, but in almost any other situation I can think of. Okay? almost. I can think of worse ones. Okay, use your imagination. So here, it's not as bad as putting your life savings on our left wheel, okay? It's not as bad as betting the farm on a poker hand, okay? Doesn't get you anywhere. This is harder to rearrange, solve for B than the original was. You can still get there. You can still divide both sides here by AC and do a little simplification. You'd have B minus 1 equals something, and it could work out, but it's a roundabout way of doing it. It wastes a lot of energy. Because at this stage, it's all okay. Still valid, but it's reverse progress. Because if you're laboring under the illusion that ABC minus AC is just B, it's not. It's AC times B minus 1. Okay. You can't undo a multiplication by subtracting what you don't like. You can only undo a multiplication, which is what you have here, by division. And you can only undo an addition by subtraction. You can only undo subtraction by an addition. You can only undo a division. Well, you shouldn't have a division because you should multiply your denominator. Okay, well, I hope I make this point because this is really important. And if you want to make good progress, you don't want to be doing this wrong. Okay, so, okay, now solve for F. Well, you want to get rid of that DE, right? Now you can't divide this by DE and divide this by DE without dividing everything by DE. So if you want to divide by DE, again, it's valid if you do it right, but it doesn't take you in the direction you want to go. Okay, and you'd have to divide both sides by DE. You can't just pick to divide the thing you want to go away by itself, right? You have to divide everything on the side. So that's why when you write down an operation on both sides, make sure you write the same operation on both sides. If you multiply both sides by quantity, multiply the entire side, each side of the quantity. Okay, now to undo this, leave myself here. Well, I can subtract DE because DE minus DE is 0. But if I was dividing by DE, I know that DE divided by DE is 1. It's not 0, so it doesn't go away anyway. Okay, so dividing by DE is a bad idea for many reasons. It confuses the equation and leads to errors. That leads to increased probability of errors, and you want to reduce that probability. If I subtract DE over here, it's going to go away, but of course I have to subtract it from both sides. Then you get what? ABC minus DE equals F because DE minus DE just gives you 0. Well, that's a one-step solution, isn't it? Okay. You have to do an addition by subtraction. If you have a subtraction, you could undo it by an addition, but you have to do it to both sides. So a lot of you were real close on this, but get selective. It's natural to focus your attention on the thing you want to get rid of and forget to do what you need to do on both sides, okay? It's a very common error when you're starting to solve equations. Okay, well, that's easy enough. And this one, and incidentally, a lot of people got this one, but didn't get this one. I'm a little, it seems like it would be the other way around, but that's okay. It means, though, that, you know what the rules are. You just got to be careful to apply them. Don't divide where you ought to subtract. Don't multiply where you ought to add, and all that stuff. Okay, so we solve it for E. Let's write it out with room to do something on both sides. Okay, well, you want to isolate E. Isolate to E here. What's the first thing we can easily get rid of? We can't easily get rid of D, because if you divide by D, you've also got to divide F by D, and you're going to end up with F divided by D. That's a fraction. You want to avoid fractions. And in solving equations, you can pretty much always avoid fractions, except maybe at the very end where you get some kind of fraction. But in the solution process, you don't want fractions. So we do ABC. Well, like myself. Okay. What those I want on this side, I don't want the D and I don't want the F, right? Which one can I get rid of in one step? The F. Subtract F from both sides. Okay. Now what do I do to both sides? Well, I'm trying to get E. It's multiplied by D, so I've got to divide both sides by D. Line that up very well, you get the idea. So we get then get E equals ABC minus F over D. Once you learn to do the same thing on both sides and to do it correctly, it's just kind of a game. You need to learn those rules and get in the habit of using them. Okay. Okay, well, we need to move on because, we're still in Algebra 1. This is the intermediate algebra course. But we've got to establish Algebra 1 before we can do Algebra 2. Doesn't leave us a lot of time to do Algebra 2, but if you stay on the assignments and learn every day to do what you need to do. Last spring, I had a class of 8 people. And one of them might have stopped coming. So he didn't pass it, but everybody else did. And half of them passed with a recommendation. You don't even need MDE 61. Just go ahead and take the 161. Okay. Officially, you're supposed to take the MDE 61. Okay. Along with it, and many people need to. So half the class do, half the class. But I ran into one of them. Hadn't seen any of them around. Really good group. Really good. But ran into one of them. Just walked down the hall yesterday. He's in 161. He wasn't one of the strongest students in the class, but he was okay. He did his work. He sat there and stayed on top of it. He's doing fine. Hope that continues because he works on it. Okay. And That's what it takes. They all showing up every day, doing the homework. Most of them are doing most of the homework. Ryder's probably doing it. I can't see it. Yeah, I watched him yesterday. He does it. He does the blame homework. And he submits it. He does everything he's supposed to do. And it's supposed to show up in the grade book, and it never does. I don't know what it is, but I'll told him to take the screenshots and, give you credit. It'll be tomorrow before I can catch up with our administrator. He's a kind of regional administrator. And he knows more about the code behind MyOpenMath. I just know how to use it. I don't even want to know the code because I got other things I've got to code with. Okay. Just finished a big project last night, about 3 a.m. So, I don't need to know that. Okay. So he's going to be able to tell me tomorrow. Or at least he's going to be able to tell me, I don't know, there must be gremlins. He'll have an answer. He's really sharp. Okay. Anyhow, there we are. Okay, we need to move on. That's the whole point of that big digression. So we've got to go on into talking about absolute values. Some people are still working on the arithmetic a little bit, but okay. Just ask, to start off with the idea of absolute value. Absolute value of negative a minus b. In my case, that might be -7 minus 5. It's not accurate from me, but so absolute value -5 minus 9 is what? Well, -5 minus 9 is -14. And hopefully you know how to add signed numbers, right? I think everybody does. Okay. And here's the key, the absolute value -14 is 14. Okay. Now here's a picture on the number line. Here's 0. And let's say here's -5. Here's -9. Here's -14, right? Hopefully you've seen this model, but maybe not since sometime in elementary school. Okay, -5 is like an arrow from here to here. -9 is like an arrow from here to here. So if you add these arrows, you can do -5 and -9. You get to -14. The picture makes sense. You kind of want to understand the number line, because if you don't, well, it's an important part of understanding arithmetic. If you can't visualize how numbers are moving on the number line, then you don't really understand what you're doing with arithmetic. And unfortunately, I think there might be a lot of that because arithmetic is now, these days, something you do by punching buttons on a calculator. And you don't have any image of what it means, and you lose track of what things mean. And then you have trouble. You come in to like a pre-calculus class or any other class based on math. You don't have any connection with the meaning of the calculation. So you want to develop that connection. So make sure you think about this picture. And if you can't make any sense out of it, let me know. Okay? We can talk about it. Okay, well, we've got 14 here. Okay? Well, okay, what's 14? Okay, -5 has a direction. It's to the left, right? This -5 is to the left of 0. If the number line is, which has an arrow on this end, indicating the positive direction is here, right? That's what the arrow means. Put arrows in both ends, you don't know which end is positive, which is negative. Okay, well, we put an arrow on this end to indicate the positive direction. These are both in the negative direction because to get from 0 to -5, you got to go to the left. To get from 0 to -9, you got to go to the left. And when you put them together, well, that means you start at 0 and you take 5 steps to the left. Then for -9, you take 9 more steps to the left. That's what these arrows indicate, right? Yeah, that's right. Okay, so what about the absolute value of negative 14? Well, the absolute value is just how many steps you take. Doesn't care if it's to the right or left. How many steps do you have to take if you go 5 steps to the left and then 9 steps to the left? Now, how many steps you take? You could take 5 steps to the left and 9 steps to the right. That would be 14 steps. So that's really not a good way to get absolute value. So it's just how far do you have to step to get from 0 to where you end up? Okay. In this case, you got to take 14 steps to get from 0 to where you end up. And we can indicate that by an arrow like this, double arrow, both sides. Well, you don't know whether that's positive or negative. So we just say it's positive, okay? It's a distance, okay? So, what I call the displacement is negative 14. It's worth kind of knowing what that word means, displacement, okay? How much displacement is there? The displacement is 14 units to the left. Displacement has a direction. Sorry, I get choked up when I talk about displacement, but it's really an emotional thing for me. Okay, I don't know what was going on there, but, and this is distance. Is 14, okay? And the absolute value is a distance. And it's always positive. Okay. Let's say that we have an equation. This is 14. Absolute value of x equals 14. How many values of x are there that make that true? The last question I asked is, give me one value that makes this true. Okay, we got an absolute value of x equals 14. Before that, I said, well, how many values of x are there, right? Then I asked, can you give me one value of x that makes this true? And somebody said 2. And I thought, this person's lost their mind. You know, the person seems to know arithmetic, seems to know some mathematics, and seems to be pretty good. So I was pretty sure that wasn't it. It was probably me that was losing my mind. Then I realized that was the answer to the first question. There are 2 ways. And then I asked for clarification, and the answer I got was, yeah, negative 14 and 14. After I processed that for 5 minutes, I said, yeah. Okay. Okay, so do we understand that negative 14 and 14 are both solutions, right? So I can say if this equation is true, x equals negative 14, because we saw absolute value negative 14 is 14. Or if x equals 14. Okay, it's because, according to my model here, out here, negative 14. Oh, that's bad. 14. Hang on. Anybody can read that? Everybody tells me they could read that. I think they're lying. No, nobody told me that. So, I can't read it from up here. 14. Now, if you can't read that, you should move those. Okay, so there's 14, right? And what did I say the absolute value is? The distance is 14, so absolute value of 14 equals 14. Okay. Now, one of the more confusing definitions of absolute value, not in terms of distance, but it's the one you usually see in a textbook, and I'm pretty sure that's what Open Math is going to try to tell you. When I saw it, I said, I mean, I've been doing absolute values for years, and then I saw that definition. What does that mean? Okay. I sorted it out, you know. The first time I saw it, I said, that's stupid. Well, not really. Okay. Absolute value of x equals x. X is greater than 0 or equal negative x if x is less than 0. I think you're going to see this. Now let's test that. Let's say I give you x is negative 14. We want the absolute value of negative 14. We're going to follow this rule. This incidentally is the way you have to write the rule for a computer to follow. Okay? Computer doesn't understand distances. Easily understand this definition. Okay. So, what did I say I gave you? I gave you 14 or negative 14? 14? Positive? Let's say I gave you 14. I don't know. If x is 14, then which of these cases applies to 14? This one or this one? Well, this says if x is greater than or equal to 0. This says if x is less than 0, right? Now, is 14 greater than or equal to 0, or is it less than 0? Greater. Greater than or equal, but simply greater. Okay, so that means you got to do this. So the absolute value of 14 is 14 because 14 is greater than or equal to 0, right? What about the absolute value of negative 14? Which side of this? Well, negative 14 is less than 0, right? Okay, so it'd be negative x. Now x is negative 14, so what's the negative of negative 14? It's 14. Okay, so and it says, if the number is less than 0, in other words, it's a negative number, you got to take its negative. That's how you change the sign of the number. So when you wrote down on your paper, the absolute value of negative 14 was 14 or whatever it was, negative 11 or whatever, okay? You did it in your head, you just changed the sign. The way you change the sign, the mathematical operation, is to take its negative. When you take a negative, you change the sign of a number. So we want to kind of understand all that. Now, when it comes down to applying absolute value sign, absolute values, there's quite a bit to it. I should take an equation here. Just talk a lot about equations right now. The equation absolute value of x minus 5 equals 7. Can you give me a value of x that satisfies the equation. Okay, not everybody understood the question. And as soon as the question is clarified, you knew what to do. Okay, and everybody got at least this result. Might not have written it out this way. Absolute value 12 minus 5 is the absolute value of 7, since 12 minus 5 is 7. He did that in your head, and everybody got it. Okay, now how many of you have a second number that satisfies the equation? Not everybody. Okay. Well, -2. Now, the way you would reason that out, I mean, you try all the numbers from -1,000 to 1,000, see which ones work. That's what most of you did, wasn't it? You're quick. You got through all those numbers quickly, and you got at least one right solution, in many cases two. Now, if you start from -1,000, you're going to get to -2 before you get to 7. So that, I guess you probably did it some other way, because most of you got 12 before you got -2. Okay, just kidding. No. You didn't do trials and error. You did use some kind of reasoning, right? And the insight would be that, well, if x absolute value of x minus 5 equals 7, then x minus 5 is going to have to be 7 or -7. Okay? You got to get a 7 or -7 in here to make it right. Now, once you see, well, I've got to get 7, well, 12 minus 5 is 7. You get that pretty quickly, right? Then you see, well, I'm going to need to get -7. How am I going to get -7? Now you have to see that. You have to get -7. And then it's pretty easy to get -7, just -2 minus 5, right? And think number line. 2 this way, 5 this way gives you 7 this way. Okay. Well, this gives us a logic for solving equations in this notion. Okay, so formally, this is equal to 7 if and only if the thing inside the absolute value is either equal to 7 or it's equal to -7. Well, that gives us two really easy equations to solve for x, doesn't it? Okay. So what happens is this equation splits into two equations. So I'm going to come up here. Okay. This splits into two equations. X minus 5 is 7, or it's -7. And then we easily solve this. We don't really need to go through this step to solve this. We can add 5 to 7 in our head. Okay. And you kind of get away with that. But still, I'm writing out all the steps because I'm going to give you one that requires you to take a couple of steps. So we do the algebra. Now we say our solution set. Is a set consisting of the two numbers, -2 and 12. And open math will explain the set notation if you haven't seen it before. But that's how we would write out the solution set. We're using braces, and this is a set of two numbers. Okay. And anything in this set is a solution to the equation. Okay, well, try this one. Solve AX plus B equals C with your A, B, and C numbers. Okay, now, some people got it, some people didn't. But what did I do here again? When I solved this equation, I said whatever's between these things has to be 7 or -7. Because we understand that the only two numbers that have an absolute value of 7 are 7 and -7, right? Okay, so at X minus 5 either has to be 7 or it has to be -7. That's the only solutions we can have. Any other value, anything that doesn't satisfy this is not going to give us 7 in here. Anything doesn't satisfy this is not going to give us -7. Okay. Probably could have said that a little better, but it comes down to this. When you have an absolute value equal to a number, then whatever is between those absolute value signs either has to be equal to that number or it's negative. Of course, this can't be a negative number over here. This is a negative number. You don't have a solution at all because an absolute value is never negative. Now, if that confuses you, don't think about it. But the whole point of what I did here is that to say absolute value something equals 7 says that something is equal to 7 or that something is -7. So if you have this, well, that would split immediately into the equation. And see, I wrote this word or, because it could be this or this. X could be 12 or -2, right? So in general, this equation got split into these two. Now, we wouldn't really write it out because what you would do with your numbers, you just put your numbers in, but whatever your numbers are, we're just going to say whatever's inside the absolute value sign has to equal C, or it has to equal -C. I'm going to get two solutions. So if the equation is absolute value 5x plus 7 equals 13, that gives me two equations. Can you write down those two equations real fast? Okay, because we have short time, I have to say this kind of focus and careful attention. Not everybody is seeing this. What did I do here? I took what's inside the absolute value sign, I set it equal to 7. Okay. Then I took what's inside the absolute value sign and set it equal to -7 for this equation, right? I put an or between these, then I just solve the equations because the equations are real easy to solve. And they're not always real easy to solve, but the ones we're going to see on. Okay, they're just linear equations. Okay, now, what am I going to do here? I'm going to do the same thing I did here. I'm going to write out 5x plus 7 equals 13. Or 5x plus 7 equals -13. Okay. That's all there is to it. Then, well, I mean, That's the first step. And once we've done the first step, everything follows. So we got two solutions with an or between them. Six fifths, -4. Now, one thing I'm not seeing people doing that I really want to kind of keep reminding you about until you get it. The thing I want to keep reminding you about is now check your solutions to show that what you got is correct. That's where you really start to believe what you did. If I put -4 in here, what's 5 times -4? Well, you don't have enough fingers. I can't ask you to answer, but it's -20. -20 and 7 is -13. And the absolute value of -13 is 13. Okay. And if I put 6 fifths in here, 5 times 6 fifths is 6. 6 and 7 makes 13. So it checks out. Okay. Yeah. And Open Math will give you good explanations, good videos, but make sure you grasp what's going on so it makes sense to you. Okay.